So, how many of you, okay, have probably been in this position? So you are working on some type of model, and all of a sudden you start banging your head. I was like, man, I need to figure out which feature, which tool I need to use for this model. Okay, it has happened to me. That I give training for SolidWorks, and sometimes a week later I'm giving the training. I'm like, you know what? I could have used that feature in that model that I was working last week. So today, what we're going to do is do a little bit of detective work, and I am going to help you, right? So especially with this webinar, you'll be able to find some helpful tool that you can use either in a on a day-to-day basis whenever you work with certain models. And perhaps if you have seen this feature before, right, but all of a sudden forgot, then you're able to just remember that the feature was there, right? That you can utilize it, and perhaps there's also some settings that you have forgotten or at least didn't know that the feature could do. So, welcome to the Evaluate tab in SolidWorks webinar. My name is Julio Calles, right? I'm an application engineer here at the SignPoint, and that's what we're going to be doing today. Okay, so I hope you enjoy it. If you have any questions, I would ask you just to please wait until the end of the webinar, and I will be more than happy to go through it. So let's go ahead and get started. All right. So what does the Evaluate tab include? So it includes a lot of many different features. Unfortunately, due to our tight time frame, I won't be able to go through every single one. So I have picked some of the very useful ones and actually quite common that we use. So some of them are going to be the design study, the interference detection, the measure tool, markups, mass properties, and so on. So you can see just a quick slide here of all of the different ones that are included. There's also express products, and this comes with your SolidWorks seat. Those I won't be going through today because that actually does take quite amount of time to go through every single one. But there's Simulation Express, Flow Express, right, DriveWorks Express, and so on. All right, so what I did is I did try to put some of these features in their own slides so you can sort of understand and have a little bit of background on what they can do. So the first one that I actually start with today is going to be the design study, okay? And the design study is a great tool whenever you almost like need to create a multiple design scenario. So some sort of evaluation where you have a common goal, right? So think about almost like getting dressed in the morning, right? You need to pick an outfit, and that is your overall goal, right? But you probably have many different outfits. I know I do, especially, and I'm someone that likes to get, like, especially in the morning, I don't do things the night before. So I usually struggle in the morning trying to pick an outfit, right? So this is the same thing that could probably happen in your design scenario where you have a part, you're trying to create a part, but that part has some sort of goal, right? It could be either a mass, it could be some sort of any relevant constraint that you may have. So how it does is that you can actually specify different constraints in the software, and some of those examples can be simulation data. Once again, for stress, either temperature, even frequency. You can also do it for mass if you want to reach a goal for the mass of your part. You can do dimensions, you can do costing data, and the costing data is also really cool. And unfortunately, I just don't have enough time to go through that sort of example. But you can set up costing in the back of the software, and then what it does is that, well, it can, given that you specify very good parameters and you set up very good templates for your costing, the software can calculate how much it will cost you to make this part. Okay, so as you are creating designs and adding features, it can update and let you know, and so on. All right, the other one is interference detection. And interference detection is just, it's so simple, but it's so important, right? So anytime that you have either an assembly level or even a multi-body part level, you want to make sure that you go through this before you send it to manufacturing, right? Last thing is you want to get yelled at by email or through the phone. because the part that you design had some collision in the middle, in between. And the interference detection in this case in SolidWorks is a static analysis interference check. So what I mean by this, by static, is that what it does is that it looks at the current positions of your assembly or multi-body part, okay? And if currently, right, it does an analysis to make sure if there's any interference in between, right? But you always need to pay attention that if you move the part, right, if you change the position, then you need to do another interference detection, okay, to make sure that at that position there's no interference. So, right, interference in other words, right, is whenever you have two parts that can either that are sharing a common value, right, so they're intersecting with one another. Okay. There's also sensors, and I love sensors because you can have them to monitor, evaluate different model properties that you can have, right? And there's actually so many different types of sensors that you can create that I just don't have the time once again to go through every single one of them. So one of the common ones are the costing, the simulation data, even math as well, to have a sensor to evaluate and monitor the weight of your part, even for, once again, for temperature and simulation. So quite heavily used. All right, another one is going to be the zebra stripes. Zebra stripes are very interesting because they help you to analyze small changes throughout the surface of your model. Okay, and these changes are usually hard to see. So what I want you to picture is almost whenever you have a phone, right? And then if that phone has a dent, I know everyone's worst nightmare. You just bought a phone, all of a sudden you dropped it, didn't have a screen protector, and now it has a dent, right? And I don't know about you, but sometimes it's sort of hard to see that dent. So you also have to play with the lighting and the angle from that you're looking at the phone in order to see the dent on the screen of your phone. So zebra stripes can help you see all those different changes, and even to extend, it can help you understand the curvature, right? The changes in curvature in your model, whether they are discontinuous, tangent, right? Or perhaps so you have a nice continuous curvature all the way throughout. All right, and lastly, if you work with models, okay, these are great tools that you should be using to help you evaluate your molds, right? So there are undercut analysis, there are draft analysis, and there's also a parting line analysis. And I'm going to make sure that I go through all of this today. All right, so I know, Julio, enough talking. Show me some cool models. Show me this example. So I'm gonna go ahead and do that. So I'm gonna switch from the PowerPoint right into the SolidWorks. So I'm gonna just change the application here that I'm sharing. Okay, I wanna make sure that everyone can see it. All right, awesome. So we're in SolidWorks. So I'm going to first begin by creating a very simple part, okay? So I have a sketch here. Just gonna create a sketch in the front plane, and I'm just gonna create like a cube, okay? We're gonna say it's gonna be 50 millimeters. Okay, this is also going to be 50, and I'm going to just go ahead and extrude this 50 millimeters more, okay? So I'll just select OK. I'm gonna assign it a plain carbon steel material, okay? So quite a symmetrical cube, right? The application of this cube, right? Let's not pretty much go into it, right? It could be for some sort of balance, right? And what I want to do in this case is that I want this cube, if I actually come here to the Evaluate tab, and if by any chance, for some reason it's not visible, right? You can always right-click now in SolidWorks 2020, come to tabs, and activate whichever one, right, you would like to utilize. So I have my Evaluate tab active. If I want to do surfaces or sheet metal, you can see that you can just simply activate them and deactivate them. And I really love it because it helps you to organize the software, right? Organize your tools so you don't have 20 different tabs that you're technically not using. So very cool thing there in SolidWorks, right? So this is here the tab that I was mentioning about, the Evaluate tab. And you have all these different features. And in 2020, they have added many different like small videos and additional information about the feature that can just help you understand, even if you haven't come back to it in a while, to remember what the feature is. Okay. So if I come here to mass properties, right, and I do mass properties, you can see that, well, I have a single part, but I'm able to this is probably one of the most commonly used features, right? Mass properties to understand the mass of the part. We can see that the density, the mass, the volume, surface area, you know, principal axis of inertia and principal moments of inertia, and just so on, right? And you can actually, I did a really good job, right, with this cube, right? So the center of mass, 25 in X, Y, and Z. Okay. So in this case, I have the mass to be 975 grams. All right. So what if I actually want the sign intent of this part to be 1,000 grams, right? So 1 kilogram. Well, it can be quite painful, right? I mean, this is a very easy example, but maybe I have to come back and then start changing dimensions and so on, right? So instead of actually doing that, okay, instead of doing the work, I can let the software do this work for me. The way that I can do that is by doing a design study, okay? And the first thing that I'm gonna do is I'm gonna specify some parameters. So if I come here, I can specify some parameters, and I'm just going to keep it very simple, right? You can specify whatever parameters you would like to use. I'm gonna do one for the thickness, okay, of my part. I'm gonna use a model dimension, and I'm just gonna go ahead and select it, okay? So I'm going to have that parameter as my changing parameter, okay? And I always like to add comments. I love adding comments to everything, you know. So thickness, and then that's it. I mean, you can specify as many parameters as you want. In this case, once again, I'll keep it very simple so you can understand. And I'll go ahead and select apply, okay? Select OK. The other thing that I'm also going to do is that I can use sensors. So if you see, right, once again, under the Value tab, I can come to sensors, and I can specify a sensor here. You can see all the different sensor types. So simulation, right, mass properties, measurement, costing data, and so on. So I'll do it for mass properties. And even for mass properties, you can see that you're not only driven to select the mass, you can also do a sensor for volume, surface area, and so on. All right, so right, my goal here is to reach 1,000 grams. So I'm going to select my part. Now just go ahead and create the sensor. All right, so now I'm going to create a design study. So I'm going to come to design study, and then in here, okay, under you have the variables, constraints, and goals if you're trying to do some optimization studies as well. So under the variables, you see that I can select the parameter that I created before, the thickness. So I'll go ahead and select it, okay? And under the minimum, okay, well, I know that the minimum thickness is 50 millimeters, right? So I actually want it to be, that's the one that I created. All right, and I'm gonna say, all right, so this is 975 grams. Probably if I do the maximum as, let's try to do 52, right? Because it shouldn't take that long. It's plain carbon steel. And then what I can do is that I can do a step. So let's do the steps of 0.2. Okay. So what I'm telling the software is that, hey, go ahead and try to change this. Do the wrench is going to be every 0.2 millimeters. Okay. Until you get to 52 millimeters. So instead of me having to do all these changes, right, to do 50.2, 50.4, I can have the software do it. And then I can come here to constraints, and I can use that sensor that I created, the mass one sensor, okay? And in here, I said, you know what? I actually want this mass to be in between 1,000 grams and, I don't know, 1,001 grams, okay? So let's go ahead. I'm gonna go ahead and hit run. Okay, in the software, as you can see, it has all these different scenarios that's gonna go ahead and try to calculate. Okay, and it'll also go ahead and show you, right, that sensor that you specified, so that constraint. So it seems here that very close to scenario 8, we are reaching, okay, 1,002.3 grams, and that's when I have my thickness to 51.4. Okay, so once again, very very cool tool to use, right? And it's very simple to set up as well, right? And you can see the power, especially when you have bigger models, on how you can specify them. Okay. All right. So enough with the design study. Let's go back and let's take a look at a couple of different other things. So the next one that I'm going to take a look at is going to be the measure, right? Once again, probably one of the most commonly used as well, other than the mask property, right? So I can go ahead and select the measure tool to measure faces. Okay, so I can get the area and the perimeter of that face. Okay, and pay attention that if I go ahead and I'm going to uncheck this point to point just for now, but if I continue selecting faces, right, then it just go ahead and tells me the total area of those two faces. Okay, and let's just continue doing so. All right, so what if I actually, I'm gonna make this here normal to me. Okay, so what if I just want to have a point from, let's say measure a point from this end right here to this end. Okay, well, you can see that if I select the face, right, and I say from that point to this point, it just selects and unselect the face, right? And that is due to the fact that I don't have the point-to-point selection, right? Now when I do the point-to-point selection, so whatever you do a click, right, a left click, it's gonna go ahead and tell you, okay, well, you have your DC distance, right, your DX distance, and your distance right here as well, right? The one that you can have. One that I actually really enjoy, and so I'm gonna show you here really quick. So I'm gonna create a sketch on the top face, and I'm just gonna draw two circles to actually show you what else you can do. Okay, so I'm gonna do a cut extrude, and I'm gonna say just through all, so it goes all the way through. Okay, all right, so now I'm gonna come back to that evaluate, and I'm going to once again use the measure tool. I'm going to deactivate the point to point, okay, because if it's active, it's not gonna be able to work. And I'm gonna say, let's say that I want to measure the distance between this circle, right, to this other one. So I'll go ahead and select it. I should select the edge in this case, and you can see that it gives me the center to center distance. Okay. Now, what if I actually want the distance from the outer point of the arc, right, for both, right? Oh, well, should I do the point to point, right? Just try to select the point and then just make sure, maybe that's actually not the right point that I have to select. Oh, guys, this is a nightmare. Let me call tech support to the sign point. Well, this is what you can do. Okay, if you select both edges, okay, you can come here all the way to the left, and you can see that you can actually change how the distance is being measured. So right now it's doing a center to center, but I can do a minimum distance, right? I can do a maximum distance as well, right? So it's from the end, right, the outer portion of each arc, right, the farthest in this case. And if I even want to do a combination, I can use a custom distance and say, you know what, for the first arc, I want it to be from the center. Okay, and from the second one, I want it to be the minimum. Okay, so you're welcome to play around with it and just make your measurements, right, work for you. You can actually do the measurement history, right, and it's just going to show you all the different measurements that you have done, as well as showing you the different parameters. Okay, all right. Enough of that. I want to show you some. Oops, let me come back to it. Okay, all right. Enough of that. Let me come back here to the model, and I'm going to show you the section properties. Right. Sometimes I hear a lot of section properties is the same as measure, and I'm actually going to show you that it's not entirely. So when I select the section properties, okay, I can select different faces. Okay, and if I hit calculate, you can see that it gives me the area and also the moment of inertia of that area, okay, as well as principal moments of inertia and so on. Pay close attention that was not available when I use the measure tool, right? It just gives me the area and then perimeter. Section properties, it can actually give you a lot more information, okay? And if you need to select two faces, as long as they're parallel, you're able to recalculate. Okay, so give you once again the area, right? And then the centroid, moments of inertia of those two faces. So one thing, right, if you're selecting more than one face, is that they have to be parallel. If one of them is not parallel, you'll see what's going to happen. All right, Julio, you're nuts, right? The selected face is not parallel to the first face that you selected. So it's pretty good giving you some feedback on when you can utilize it and when you cannot do it. Okay. Another one that you can also use is the performance evaluation. Okay, and I'll come back to it here probably a couple of times as we go through some different models. Okay, and the performance evaluation is great because it helps you to understand how this part is literally extracting resources from your computer. Okay, so you can see here that it will tell you the total rebuild time, so about 0.02 seconds, and it tells me that, all right, this cache is actually taking the most amount of time. Okay, so as you come to more complex models, it can help you understand, okay, you know what, maybe I shouldn't be using this feature. It's probably creating some using too many resources as expected. Can I use a different feature, right? How can I make this open a little bit faster? So it helps you understand perhaps what you need to suppress. Maybe you need to use a freeze bar and so on. Okay, but it also gives you the number of solids and the number of features that you have, right? So if you have a multi-body part, it's pretty quick to tell you, okay, maybe you have 5, 6, 7, 8 different solids, and same thing with surfaces as well. Okay, all right. So let me go ahead and switch to the next one. So I'm going to show you, in this case, the evaluating one. Okay. All right. So I have some skateboard here that I have created, okay, with our lovely design point color. And what I'm going to do is, once again, if I can do the performance evaluation, right, and I can see how it's being affected, right? Once again, the number of features, solids. You can also do it at an assembly level. Okay. So it tells me here the sense that this last fillet is about 66%. Okay. And by the way, in this one, I did use some GrabCAD models. So I used the GrabCAD website quite often to work on some personal projects. So in this case, I actually have, I used a GrabCAD model, and then I just try to recreate it myself. Okay. And we're going to see some different tools that we can use to evaluate that. All right. So if you need to ever just check your geometry, right, just do some normal analysis of your geometry, you can use the check tool. Okay. And what it can do is that it can check your model for many different things. It can check them for invalid faces, invalid edges, short edges. And you can do it either at an entire part level, or you can also do it by selecting different items. Okay. Or perhaps different features, right? So you can select bodies and features as well. So since I only have one, I'll go ahead and have the all selected, right? And you can do solids and surfaces. I'm just going to do solids in this case. And then you can see if you have any open surfaces. If you would like to find out what is the minimum radius of curvature of your part. Do I have any maximum edge gap, right? Or the maximum vertex gap? So I can go ahead and hit check, and you can see that it will actually go ahead and show you, it will point you, hey, it's right here. This face in your model has the minimum radius of curvature. And it also gives you the value. So it tells you it is 2 millimeters, right, for the radius. It will actually show you where your maximum gap is, right? So in this case, it would be for the edge gap. And let's take a look here slowly, right? And it tells me it's about 5e to the negative 6 millimeters. So it's pretty small, right? But perhaps you have, when you create your part, it could actually be a little bit bigger, right? So it could be an area of attention that you perhaps will need to investigate further what is going on. And you can also do the vertex, and in this case, it should be located in this other side. Right? So once again, it goes ahead and show you where it's located, as also showing you the value. All right, I'll go ahead and select OK. All right, and another one that you can also do. So as I was mentioning, I use a model, okay, and I should try to based on that model recreate it. Okay, so if I actually just bring this back right before I did the body delete feature, right, you can see sort of what the model that I have, and you see that I have two solid bodies, right? So this is the imported one that I brought, okay, and then I have the one that I created, okay. So if you need to just use a tool to help you compare, right, volume to volume, you can actually use the body compare tool. Okay, so the body compare tool, you can select your source body and the body that you want to compare it to. So I'm going to select, come here to the solid bodies folder. I'll select that imported model, and then for the compare bodies, I'll select the cut extrude. Okay, and what is really cool is that it goes ahead and shows you, and you have all the different color settings here with the legend, letting you know, okay, where the deviations are happening, right? So in this case, you could have up to 30 millimeters of deviation and minus 13 millimeters of deviation, right? 13.5. So if it's green, it's good. That means that all in that area, right, it's about a 0 millimeter. So we are right on. Okay, so I'm actually going to hit OK, and I'm going to show you that you can actually now start making changes and see if those changes are actually, how do they affect, right? How do they compare to the previous feature? So I'm just going to add a fillet here. Okay, I'm going to say, I don't know, 2 millimeters in this case. And you can see now, all right, look, you see how the colors change? So this is probably closer between 4, right? So 4 to 6 millimeters. Okay, in deviation compared to the original model, right? To the part that, the source part that we utilize for this. Okay. All right. So another one that you can use, and I'm just going to bring it in this case all the way to the imported model. Let me go ahead and show it. It's going to be the deviation analysis. And the deviation analysis is going to help you analyze the angles in between faces. Okay, so I'm going to go ahead and select this right here on top of the zebra analysis, which we'll come back in a little bit. Okay, so you can just select the different edges. Okay, so I'm going to select these edges here, and once you hit calculate, it'll go ahead and give you the deviation in between those faces that are for you, right? So you see that I have a maximum deviation of about 49.97, right? The average in here, and it's also color coded. Okay, so 45, and it seems like it goes about 1 degree, right, total of deviation, right? And you can just continue adding them. So let's come back in this case to this area. I'm going to add them here, right? And as you can see, there's actually, I don't have that many points, right, to get a better understanding. So I can just use this leveler to increase my number of points, okay, to get more of a more accurate, right, better understanding. There are more data points to extract. Okay, so once again, very, very cool to use. Right? You see how you can utilize it using just by simply selecting the edges. Okay, so I'll just go ahead and select cancel. Okay, and now let's just go ahead, and I hope that you're strapped in, because we are about to land. All right, so I have this very cool model, and actually I did grab this one from GrabCAD as well. I love planes, and that's one of my colleagues, Ryan Borger. So as you can see here, I have a model, right? And what I'm actually going to do is just do some further analysis, right? So to do that, I'm going to just open the plane section alone. Okay, and this is where I have the plane. Okay, it's an Airbus A320. And what I'm going to do is, all right, let's actually do a couple more things. I'm going to use the geometry analysis in this case. And if you see here on the left, you have your insignificant geometry, right? And if you need to find any short edges, any small faces, and silver faces, and you can actually specify what you can constitute what is to be a short edge, right? So it would be, in this case, anything that's below this distance. So any edges in your model which are less than 0.10 centimeters, right? It will go ahead and show you. A silver face in the software is any faces that have a high aspect ratio, right? So this is how you can also find them. You can also do it, what is it called, like sharp angles, and you can do a knife edges and also do knife vertices. And what a knife edge, sort of how SolidWorks defines it, is any edge where the angle between the two adjacent faces is acute, right? And then the vertex is the same thing, but in this case, it would be any two adjacent edges instead of faces, right? So, and if two adjacent edges, if the angle between them is acute, then it will state it as a knife vertex. So if you do obviously some regular simulation, right? The knife edge is actually is a good point to investigate, because if any of those knife edges, that can actually involve into a very like undesirably dense mesh, right? So many different things can happen there, right? So now you might have to add some mesh control and so on. You can also look for discontinuous faces as well as discontinuous edges. So here on the left. And once again, so some of the definition that SolidWorks mentions here for this is that the discontinuous geometry as far as the face is any particular face where the underlying surface geometry is position, right? It has some sort of position or tangent discontinuity. And for the edges, same thing, right? Any underlying curved geometry where it could have some either position or tangent discontinuity. So I'm going to go ahead and just simply hit calculate, right? You can specify the degrees in this case. So I'll hit calculate, and it could take, based on this model, it could probably just take a couple seconds to run. So it goes ahead and tries to detect all of the different knife edges, right? The knife vertices and so on. So you can see that it has quite a large number of edges in this case. So it says about 7,567 that it needs to detect. And I'll show you really cool here as soon as this is done, how you can show you. It's very similar to the check tool that we previously used. So given that this is obviously more of a complex model, I wanted to show you, and it actually doesn't take as long. But obviously, more simple models, it'll take just a little bit less time. All right. Just give it a second while it finishes loading. Okay, and I didn't even check to do the insignificant geometry because we did something similar using the check tool in the software. So, all right, it's right back on. So as you can see, it's found 26. Seems like it keeps increasing. All right, we are close. Now it's looking for discontinuous faces. Okay, I like that it tells me what it's doing, right? It doesn't just say loading. So at least I know that it's not just watching Netflix in the background. All right, so you can see that it actually found 0 knife edges, 0 knife vertices, and that is based on the amount of degree that I put in. Okay, so I put only 1 degree, but it did found several discontinued edges, right? And if you zoom in, once again, if you select it, it can actually show you those edges, right? There are perhaps discontinuous. Should be another one on this side here as well, okay, and so on. Okay, and even though it didn't find them, I actually want to show you just a quick thing on what could be considered a knife edge. Okay, so perhaps whenever you have these 2 edges, right, coming in together, there could be a portion where they could actually come in between. So that can also be considered a knife edge. Okay, and knife edges, usually the endpoint tends to be what is called a knife vertex, right? So this is sort of what it can look like in your model. Okay, so perhaps that is part of your design intent, or perhaps it isn't. All right, so the other one that I wanted to also show you, it is the zebra stripes. Okay, so let me go ahead and select it, and you can see that for the zebra stripes, you can actually do it for horizontal stripes and vertical stripes, right? To further understand, right, curvature, right, changes in surfaces of your model. So you can see that it does almost like it shows you almost like the zebra here. Okay, and you can see how they're quite continuous, right? So quite continuous, right? It means that the curvature in that area is continuous all the way throughout. However, as I come here next to the wings, okay, you can see that the lines are no longer consistent, right? They're stopping. So in here you can just find where it's going to be some sort of edge discontinuity, right? And then actually etch this continuity. I wonder if I can use the drawing tool here. So I'm going to show you sort of what could be an example of an edge continuity, right? So you can have just something like this, right? And then it just happens at a different edge. You can also have tangents, right? Where it just sort of comes a different one. So so on. You have many different ones that you can utilize. Let me just erase all these different drawings and go back to the normal drawing mode. Okay, and then you can see here, okay, once again how it goes from one phase to the other one, and it's actually quite a smooth transition. Okay, and so on. Perhaps other ones we could have not a smooth transition, so it perhaps could be some tangency. But what is cool is that as you move your view, right, it's going back to sort of how the software defines it. It's just trying to reflect long strips of light onto your surfaces, okay, to help you analyze them. Okay. The other one that you can also utilize is called the curvature tool. Okay. And what it's going to do is just going to evaluate the curvature of your model. Okay. So you can see areas where it's pretty dark is where you have pretty much almost to 0 degrees. And as you move your mouse, it will go ahead and show you, right? So you can see the curvature in this case is about 0.00 radians. Okay. And also give you the radius of the curvature. So, you know, obviously areas where it's red, right, areas of interest. Okay, so you can see here around this back of the wings about, you know, 3.2 radians, you know, so same thing over here, right? So you have different areas of curvature and so on. Okay, so you can do this especially when you have any imported model or, you know, just to further understand your part, you know, especially even if you work with mold models. All right, so enough with this one. I want to make sure that I don't forget the next one. So I'm going to go ahead and open another model. And let me actually just turn off that curvature tool so I'm not using any resources in the background. So I'm going to come here to my large office. Okay, and this is actually me here in our Lancaster office. So you see I have my desk, right? Myself, okay, working in SolidWorks, obviously, probably doing some simulation projects. But, you know, one thing that you can always, once again, going back to the whole making sure that you go through some sort of process, right, before you send the part to manufacturing, is definitely doing some interference detection. And in this office that I have, I actually went ahead and I do have some interference happening. So I did make it on purpose. Okay, so I'm going to show you once again. Come to the Evaluate tab, and I'm going to use interference detection, and it's so simple to use. By default, it's going to go ahead and utilize the assembly. Okay, so but you can actually select different components if you have them. You can just do right-click, clear selections, right, or delete, and then just select the components that you would like to do it on. So once you hit Calculate, okay, it will go ahead and show you the amount of volume, right, for the interference that is happening. And what is really cool, it actually shows you which parts are actually interfering with one another. So you can see that I have an air vent and I have some sort of a lid, right? So if it rains, it doesn't go all the way through. I don't know, I definitely just made that one up. But yes, I see I have the lid, and it says that this lid is interfering with that air vent, right? So, you know, in this case, I can go ahead and just suppress that lid. Okay, and now I can go back to the interference detection, hit Calculate. All right, so there's no interferences, right? So at least I know that I'm good in that aspect. Okay, and I can go ahead and continue to move forward. All right, so let's take a look at another one. So let me come here to my mask body. Once again, one of the grab cut models. So I also have almost like a mask. Okay, and this mask perhaps is going to be done using, it's going to be manufactured using sort of mold process. Okay, and what I want to show you here is actually this right here, the draft analysis, undercut analysis, and parting line analysis tool. So draft analysis is great whenever you need to understand perhaps if your part needs to be added some draft, right? If it requires some additional draft, or if you're good, if you're set, right? So the first thing that you need to select, I usually like to, you can select, I mean, a face. I'm going to select the plane in this case, and you're going to select that reference to show what the pull direction is going to be, right? So it's almost like how it's going to come out of the mold. And then you can tell, based on um, the manufacturing constraints that you may have, right? Like what is the amount of degrees that you will need, okay, for those parts to be drafted in order to successfully come out of the mold. So as you can see here, right, I have 3 degrees, right? And it seems that in this case, I have what is my positive draft, and then the yellow faces are going to be the faces that are going to require some draft, okay? So you can see it also gives you, right, it can read the amount of degrees for those faces as well, okay? So very simple to use, right? Let me go ahead to the other one. So the other one is actually going to be the undercut analysis. And this one is really important because what it's going to do is going to help you identify and visualize any trapped areas, right, on your molded parts that could prevent the part from coming out of the mold. And then when you use the undercut analysis, you actually have 2 different things. So you can actually do a reference geometry for the direction of pull, or you can use your parting line analysis. So I'm gonna just come back and use the front plane again, right, for my parting, for my direction of pull. But if I had some sort of parting line, I could have also selected, okay? And then in here, you can specify, which direction it's gonna go. So you have direction 1, right, how it's going to come out of the mold. So SolidWorks calls it direction 1 undercut, and their definition is pretty much any faces that are not visible from above your parting line. So this usually, in other words, could be perhaps your core faces, right, where the depends on how the plastic, right, is being injected into the mold, and then you also have your direction 2 undercut, which they like to call it, any faces that are not visible from below the parting line. So in this case, right, it could be anything that's going to be touching the cavity of your mold, okay? And then occluded undercut and strato undercut, those are the areas that you perhaps need to investigate a little bit further. So the occluded undercut is going to be any faces that are not visible from either above or below the parting line. And we can actually take a look all of the different ones here that we have. And even if I do just a different view, okay, you can see that they're really not visible, right, from either one, okay, given the direction of pull that we have done, okay. And even for the direction of pull, you can actually use the adjustment triad, right? So perhaps it's not going to be 100% parallel, perpendicular or normal to that plane. You can actually use this triad to add some sort of amount of degrees, and you can see that it actually goes ahead and updates, okay? So definitely very cool to use. So the strato undercut, this is, I'm not gonna go 100% in between, just because it does require a little bit more of understanding. Technically, whenever this happens, so a strato undercut, SolidWorks mentions any faces that have undercut in both directions. Whenever you have occluded undercut, right, you may have to add some lifters to your mold. But for strato undercut, it just takes a little bit more to investigate, because a lot of times it can just be, a fillet, or perhaps an area. I'm actually going to show you here, so you can actually show them and hide them, right? But you can see here for the strato undercut, there's actually some fillets here that are showing, okay, and some different faces, okay, that are considered strato undercut faces. So those are areas that you perhaps are going to have to do a little bit more research, perhaps contact either your manufacturing company that makes the molds, and see how they are going to face, right, how they're going to come up and try to make those areas there for that mold. All right, so given that we're just running a little bit short in time, I still want to go ahead and just finish here with the symmetry check and the thickness analysis. So the symmetry check is a great tool if you need to find out if your part, right, is symmetrical or not. Right? So you can just select a different your plane of symmetry. So in this case, I'm going to use the right plane of symmetry, and then you can just simply select check, and it's going to go ahead and try to calculate if perhaps this part is symmetrical or not. Okay, so perhaps you need to come back and change some features in your design to make sure that it works. Okay, so actually great news for us, right? This part is symmetrical, right? Completely symmetrical. If you have any unique faces, right, it can actually show you what those are, or any asymmetric faces as well. It can show you, right? So very cool tool to use if you need to evaluate the symmetry of your part. And then the other one, the last one that I will be going through today is going to be the thickness analysis. Okay. Also can be utilized in molds as well. So you can actually specify in the model what is going to be if you want to looking for thin regions and thick regions. So what it can do is it's just a good way to understand perhaps if you how is the thickness variation throughout your part. Okay, so you can specify once again thin, thick, right? I'm gonna do a thin one in this case, and you can tell the software what is the target thickness, right, that you're looking to obtain. And here under the color settings, you can specify a continuous or discrete. In this type of scenarios, I like to do discrete just because I like to see quite a abnormal difference, right, between the different colors that you can specify. And you can also go ahead and change your scale here a little bit just to add a little bit more colors in between. If you want to, you can actually select different faces. So right now, if I select calculate, it's going to look at the entire part. But if I use faces for local analysis, then I can specify specific faces that I want to understand the thickness on. Okay, so I'm just going to go ahead and hit calculate. Let's give it a second. Okay, and I think I'm forgetting just one last feature that I want to go through. So it's going to be the parting line analysis, which is also very important in the mold models, right? So how you're going to split your mold. So as you can see here, right, it shows you, right, in green. So you have all the way from 0.1, right, closer to where your target thickness is going to be, and all the way to the red ones are going to be very thin regions in this case, right? So if I were to select the show thick regions, it would have doing different. Right, so you can see the different areas, right, that perhaps you might have to make some changes to if necessary. Okay, and what is really cool is that I can actually create a report. Okay, and I love the report that it creates. I'm actually going to show you. So I'm going to do save report, and then in here you can call it the report folder name. So I'm going to just call it mold report. Okay, and I'll do you can actually add a couple other ones. I'm going to come here to options, and I'll do a couple additional views so you can see, you can actually add different views to your report. So I have the front, back, isometric. Let's just add a bottom one, why not, as well. Okay, and I'll just hit OK. Now when I hit save, it's gonna go ahead and create the report for us. Okay, and before I show you the report, let me just come here and show you really quick, because this is pretty simple to use, the parting line analysis. What the parting line analysis is going to do is going to help you investigate the best way to split your mold. Okay, so let me go ahead and just select, in this case, the front plane. Okay, and in this case, right, we're not really seeing anything, but as soon as I show my triad, you can see that the software just tries to go ahead and calculate your the split line, you know, based on that pull direction, what the best split line would be. Okay, or parting line, in other words. Okay, so it's always good to utilize and make sure that perhaps you're using the best parting line for your model. So let me just show you lastly what the report is going to look. So let me just show my screen in this case, and just gonna come here to the mold report. Okay, so you can see here, right, it calls the thickness analysis report. Then you have your report name, right? It has the options that you use to conduct your analysis. It gives you a summary, right? Total surface area analyzed, maximum deviation from target thickness, further details, right, on the number of faces between that range, any critical features, right, that are part of those. And it also gives you the different views, right? So you can actually go ahead and add this to your report, right, if any changes need to be made. All right, so let me stop it right here. Okay, and all right, yeah, I hope you found this webinar useful. Thank you very much for everyone for coming in.